Hello, and in this video we're going to be looking at absolute value functions. We're going to start with the definition. The definition of an absolute value function, that would be the absolute value of x. That would be the absolute value of x. It's going to be defined in two pieces because it is not a smooth curve. It's going to be x, the value of x when x is greater than or equal to 0, and it's going to be negative x when x is less than 0. So the absolute value of x is two pieces. It has a right hand side that goes up at slope 1. That's this piece. And it has a left hand side which it comes down at negative 1 to this value. So we can graph this one at negative 1. So the slope here is negative 1 and the slope here is positive 1. Some of the properties of the graph is that it always looks like a V shape. It's V-shaped. And it always has the point, what we call a vertex type point where the two pieces connect. Alright, now when do we use the absolute value function? Well, the absolute value function is used to find all values that are a certain distance away from a number. Or the absolute value, basically just the standard one can represent the distance from 0 on the number line. Because when you're talking about distance can't be negative. And if you look at this graph, none of the values for f of x or absolute value of f x is negative. All these values are positive up here in the y's or f of x's, and it can be represented by this number. Okay, now if we want specific values, like we want a distance of 3 from the number 8 instead of from the number 0, then we would change the absolute value problem to from the number 8. So we're moving away from the number 8 and the distance is 3. So this would be the equation that would describe all of the values that are 3 away from 8. Now if it says within, that means that that's going to be less than or equal to 3. Because it's within that value. Okay, these are equal to the distance. So this is giving you exactly the distance that's 3 away from 8 on the number line. It would be the number 5 and the number 11. But this would be the equation that would give you the 5 and 11. And this would represent any number between 5 and 11. All right. Now these things to the graph of the absolute value of x are transformations. So when we do this kind of thing, we're moving away from 0 and transforming the equation and the graph. Now we have a standard set of transformations. So f of x, the transformations that we're going to use in this thing, or y, you can also write y here, they might write y, is going to have some value that's going to be, we're going to use some value in front of the absolute value. We're going to use a transformation here. We'll use h for its transformation and k for this transformation. So we're going to use a, h, and k as our transformation values. They're going to move the graph, so we're going to move vertex to hk, whatever h is and k is up here, and we're going to change the slope to the value of a. All right, so instead of 1, that's going to be our slope equation. So let's do an example here, and we'll look at this specific thing. Let's say f of x equals negative x, or negative absolute value of x plus 3 plus 4. Okay, now in this problem, our h is negative 3, because in the equation it's negative and here it's positive, so that's the opposite of that. And k is 4 here, so we're going to move to the vertex to negative 3 and 4. So negative 3 and 4, 1, 2, 3, 4. This will be my new vertex. That's where the v is going to come to. Now my slope here is negative 1. So that means from this point I'm going to go down with the slope of 1 on either side of this. So I would go from here and go down this direction. That's actually a positive slope, but we're going down from the vertex down 1 over 1, and we're going to go down 1 over 1 going this direction, and a negative slope. So the positive slope would change to negative, and the negative slope would change to positive because of that negative value there. So this used to have a positive slope and this used to have a negative slope. We would change those slopes to the opposite values and go down. Now if we have something that's not written in this form, so if we have like this, f of x equals absolute value of 3x plus 9 plus 2. So what we would do there is we would factor out this 3, and we would then take the absolute value of it and we would change it to the right form. We could factor out that 3 and take the absolute value of it because it is a number, so we can do that. We can't do that with the x plus 9. I'm sorry, we need to factor that, so that's not correct. That is x plus 3 here. Because 3 times 3 is 9, so x plus 3 plus 2. So on this graph we would start out at negative 3, so our h is negative 3 and our k is 2. So negative 3, 1, 2, 3, up 2, we go to here for this one. So this one starts at negative 3, 2. And we have a slope of 3. So on this side, we just go, instead of positive 1, we go positive 3. So 1, 1, 2, 3. So we go up 3 and over 1. So we go like this on this side, and on the other side we have negative 3. So we go down through here. And this would be our graph. Okay, so that's transformations of the graph based upon 3 values that you're going to look for. But we're always moving the corner or the vertex point first, looking at the vertex and then looking at the slope. Now if we have a graph and they want to know this thing, then what we're doing is plugging in the value. So in this one, the vertex here is negative 3, negative 2. Alright, so that means that our h is going to be positive 3 and our k is going to be negative 2 because it's the opposite in the function. And our slope here, well, let's look at it this way. So it goes 1. So it rises 1. So here's another point on the graph right here that we can count to. So this would go up 1 and over 3. So that means my slope is 1 over 3. It's going up, so it's positive. If it was going this way, then it would be negative. So this equation for this one would be f of x equals 1 over 3, because that's the slope. Absolute value our h is 3, so it's x plus 3. And then k is -2, so it's -2. So this would be my equation for this graph. Look, finding the vertex and the slope of the pieces. So we're going up here, so it's a positive slope on, or a positive number that's in front here. Okay, in the next part of this section, they're going to ask you to find the intercept. So they're going to ask you to find this point and when this would cross the intercept here. So they're going to give you an equation and ask you to find the vertical and horizontal intercepts. Now remember, the vertical intercept is the y-intercept, and the horizontal intercept is the x-intercept. So when we're asking for vertical and horizontal intercepts, what they're going to do is they're going to give you a function. Let's try with this one, f of x equals 4x minus 3 plus 4. Okay, now the y-intercept, the x-intercepts should be pretty relatively easy. X-intercepts, you just put in, I'm sorry, the y-intercept should be relatively easy. The y-intercept, you put in 0. Okay, so for the y-intercept, so y-intercept x equals 0. So that means that you're going to just put in 0 right here. So you'd go f of 0 equals 4 times 0 minus 3 plus 4. So in that case, this is going to be -3. We take the absolute value of that, that's +3. So we're going to get 4 times +3 plus 4. So that's going to be 16. So my y-intercept is 0, 16. Now the x-intercept is going to be when the equation equals 0. All right, so x-intercept, or the horizontal intercept, is when f of x equals 0. That's the vertical intercept. I'm sorry, the horizontal intercept. Horizontal intercept is this one. The y-intercept is when x equals 0. So what we would do here is we take the equation and say 0 equals 4 times x minus 3 plus 4 and solve that to see what the solution is. So to do that, the first step would be, I need some more room, so let's move this down. Move this down so that we have more room to work here. Okay, so we would solve this equation by moving the 4 over to here. So we'd have -4. We'd subtract 4 from both sides. We get 4 times x minus 3. Okay. Then we would divide by -4. Or I'm sorry, +4. We divide by +4 on both sides. Divide by 4 here. Divide by 4 here. We get -1 is equal to the absolute value of x minus 3. Alright, so then what we would do is we'd ask, when can this equal 2 different values? Now this one is going to be, when is the absolute value equal to -1? Well, the absolute value, if we go up to here and look at the absolute value is always bigger than 0. So it's a positive value. So this is never going to happen. We can never have an absolute value that has a negative value. when we take the absolute value of something, it always changes it to positive. So this is going to have no solution to this problem. So that means that it doesn't have an x-intercept. No x-intercepts. Okay, so there are no x-intercepts to this problem. Okay, now I'm going to solve similar problems in the next part. So we're going to go through solving equations using this method from here for the next section. So I'm going to go over some more examples, but this is how you would solve this up to this point. There's going to be a couple more steps. We're going to go over those in the next section, solving equations with absolute values. So if we have an example of 3 times 5 minus x equals 5, we're going to be able to solve that using a process. So same process we had started here, we're just going to continue on. This one, the first step is we don't have a number here to add it or subtract, so the first step here would be to divide by 3. So we divide by 3 on both sides. So we'd have the absolute value of 5 minus x equals 5/3. Now this can happen because it's absolute value and it's a positive number here, so this can happen. So what we would do there is we would use this piecewise definition up here to write two different equations, because that's what we have here. We have two different equations. So when we're solving an absolute value, we'd have to have two different equations here because we're basically having two pieces. So in this case, the two pieces are going to be, when this is going to be positive, 5 minus x equals positive 5/3, and the other side is when it's negative, so 5 minus x equals negative 5/3. So this is going to be our two different solutions, because if we had a 5/3 in here and we took the absolute value, we would get 5/3. If we had a negative 5/3 in here, whatever it was, negative 5/3, we take the absolute value of it and it would be positive 5/3. So we'd have those two different processes. Okay, so let's look at solving both of these. You'd subtract 5 from both sides. So you get negative x equals, let's see, this is 15/3, right? 15/3. 15 divided by 3 is 5, so 15 from that's going to be negative 10/3. Okay, so we get x is 10/3 here. On this one, or on this one we subtract 5 again, but now we're subtracting from negative, so that's going to be negative 20/3 because we had 15 and 5, they're both negative. So we'd have this, and then we divide by -1, and we get 20/3 as our other answer. So if I were to put 20/3 in here and subtract 5 from it, then multiply by 3, I would get an absolute value. I would get 5. If I put 10/3 in there, I would get the same 5 out of the thing. Alright, so that's solving an absolute value. Alright, let's do another example of this type. Let's put all of them together here. Let's do 5, absolute value of x minus 4 minus 7 equals 2. So this we're going to have to do every step that we can here. Okay, so first step, we would add 7, because we're trying to isolate this absolute value of x minus 4. We're trying to get it to be by itself so that we can write the two equations for the absolute value. So we add 7, we'd get 9. Then we're going to divide by 5 to get rid of this. So it's going to be absolute value of x minus 4 equals 9/5. I'm going to leave it like that. If you want to, you can make it a decimal. It's a nice decimal. It's almost 2, so it'd be 1.8 if you want to put that in there instead. But then we're going to need to split this up. Now that we've isolated the x, the absolute value, we have the absolute value of something equals 9/5. So we're going to have that something, x minus 4, is going to either equal 9/5 or it's going to equal negative 9/5, because we could have a positive or a negative 9/5 in there and take the absolute value of it and get positive 9/5. Okay, so we would add 4 to both of these to get the solutions. Both of these equations we would add 4. Now 4 in fifths is 20. So if we add 20 to this, we'd have 29/5 is the first answer. And our second answer is 20 minus 9, so that's 11/5 for our other answer. Okay. Now, the other part of solving is inequalities. Now, we have inequalities in this process because we want to be greater or less than a certain value, or the distance is greater or less than a certain value. Now, there's two types of inequalities. That there's going to be two different types of solving. We're going to have the one that's less than and the one that's more or greater than. And they're solved differently. Less than, we're going to be looking for values in between. And then greater than, we're going to be looking for values farther away. Okay, so if we have, let's say, x minus 3 is less than 7, then we're looking for values that are less than 7, between 7 and negative 7 away from this thing. So the transformation for this graph, since we're looking for values in between, we're looking for values between 7 and negative 7 because of this value. Alright, normally we write this as an extended type problem. We're going to write this as, oh, it's in between 7 and negative 7, so we're going to put negative 7 on the lower side and positive 7 on the positive side. We're going to say it's between, so it's going to be less than this, but greater than that. So greater is over here, so we just put in the value, oops, not that value, the value of the equation here in between that. So our equation is x minus 3. It's between these two values because it's less than. And so those are border values. We would then treat this as a compounded problem, meaning that we can, when we simplify the middle just to x, that means we would add 3 here. To do that, we would have to do that in every part of this inequality. So we'd have to add 3 to the first part and add 3 to the second part, or third part of this, to get the x is going to be in between two values here. It's 10 on this side because it's 7 and 3. Negative 7 and 3 is negative 4, so that means my values are going to come out between negative 4 and 7. Or I'm sorry, negative 4 and 10. We could write that as interval, negative 4 and 10. So that's our interval. Okay, and then that would also be the solution. Now greater than, if we look at the same exact problem, let's say I was doing exactly the same problem, except I was looking for values that are further away by 7. So that means it has to be greater than 7 or less than -7, because it's got to be on either side of that. So we would write these two inequalities. Now we can't write a compounded one because it's not in between. It's one's further away to the right and further down than -7. So what we're doing is we're looking at, on a number line, we're looking at things that are further away on the right than 7 and way down here at -7. So we're looking at the two equations being x minus 3 is greater than 7, or x minus 3 is less than -7. So we're looking for both those equations. Now, since we already solved this here, we're going to add 3 to these, just like we did over in the other one, because it's the same equation. But our solutions here are going to be x is greater than 10 or x is less than -4. So basically what we've done here is we've looked outside of this interval. So when it's greater than, it's outside of this interval. It's greater than 10. So it's going to be 10 to infinity, with the other one, which is going to be -infinity to -4. So we're looking outside of this range if we're greater than. Greater than, we look inside an interval. I'm sorry, less than, we look inside the interval, less than. But greater than, we look outside that interval. So this is the solution, or you can write it with two inequalities. You can write it as x is greater than 10 or x is less than -4. Okay, so those are the differences between greater than and less than. And this finishes the absolute value section.